Hi pals, today we're going to be discussing oxidation number, radical and valency under calculation and chemistry. So when we talk about oxidation number, what is oxidation number? Oxidation number is the hypothetical charge an atom of an element has in a given molecule or compound. It is simply the assumed charge the atom of an element would have as a result of the amount of electrons that can be given out or gained in the course of a reaction. Oxidation number shows how electrons are transferred in a redox reaction, and it helps to showcase radicals. Now, the fact is this. Every atom of an element, we talk about a given element. All atoms of a given element could be said to have an oxidation number of 0. That is, for the fact that there is no reaction yet with another element, we can assume that the atom of an element has no oxidation number. But it doesn't mean that the atom of an element doesn't have an oxidation number. Now, when we talk about oxidation number, we are simply talking about what that element or what the atom of that given element will likely do if there is a reaction with another element, with the atoms of another element. So when we look at the atom of a given element, we can assume that, okay, this is the amount of electrons that will be given out, or this amount of electrons that will be brought in, provided there is a reaction between this very element and another element in a given compound. So that's what oxidation number is. So oxidation number is very, very important. When it comes to redox reactions, it helps us to know how electrons are being transferred from one point to another point. Very, very important. And also, if not for oxidation number, there will not be anything like radicals, which is the next thing you're going to be looking at. So the combination of various oxidation numbers of different elements, atoms of elements, bring about what we call radical. So oxidation number is simply an assumed radical, an imaginary radical. Let me use that. Let me put it that way. So quickly, what is radical, or what are radicals? Now, radical is an atom or a group of charged atoms. It is simply the resultant unpaired atom following the reaction of atoms of element. It could be positive, which we call cations. For example, calcium radical, or it could be negative. We call them anions, which is for example chlorine, and also it could be neutral. For example, OH, hydroxyl. Now, this hydroxyl is not like they don't have unpaired. It's not like they don't have unpaired electron. They have unpaired electron, but overall they don't have any charged, electron. So when we talk about radical, as I said under oxidation number, the combination of different oxidation numbers of different atoms of elements bring about radicals. So for oxidation number, it's an assumption of what could be. But when we talk about radicals, radical is not an assumption. The whole thing has been done, reaction has taken place, and now we know what it is. We know the element that gave out electrons, and we know the atoms of element that brought in electrons. So radicals are either positively charged radicals. When we talk about positively charged radicals, you're talking about atoms of element that has given out some electron to become balanced, while the negatively charged radicals are atoms of element that has brought in or taken in certain amount of electrons to become balanced also. So we have positively charged radicals known as cations, negatively charged known as anions, and the neutral ones, so that's that for radicals. So the last thing we're going to be looking at before we take a couple of calculations is what we call valency. Now, valency is the combining power of an element. Now, when we talk about valency, you're talking about the combining power of an element. Here, we are not talking about oxidation number and radicals also, really. Although the valencies are gotten from oxidation numbers and radicals. Now, it is the amount of atoms of an element that can combine with or displace an atom of hydrogen. They aren't known for their charges, but are potent tools for writing chemical formulas for compounds. Now, the valency are very powerful tools for writing the chemical formulas for various compounds. So without valency, there's no way we can write chemical formulas for various compounds. And valency themselves are gotten from mainly oxidation numbers. But this time around, we are not talking about if a given atom of an element is charged. We are talking about their neutral state. We assume that the oxidation number of a given element is already neutral. That is, how do we achieve that? We achieve that by comparing them with hydrogen atom, which is a protos, which is the first ever atom. So when we do that, we end up having an atom of an element that does not have charges at all. So here we are going to be looking at a couple of simple examples that elucidate oxidation number, radical, and valency. Now, when you look at this carbon has an atomic number of 6. Now, when we talk about atomic number, you're talking about the amount of proton that given element has. According to Henry Moseley, elements are arranged in the periodic table based on atomic number. So carbon has an atomic number of 6. Now, we're going to be probably using the first 20 elements. Now, according to electronic configuration, the filling of shells and the rest. We have the first shell should have a basic 2 electron. The second shell should have 8. The third one should have 8. I don't want to go beyond this level. Just, you're talking about the first 20 elements. So when you look at carbon has an atomic number of 6. So how do you think carbon will fill out these? How do you think carbon will fill out the shells with electrons? So since carbon has an atomic number of 6, it means this is the best case scenario. The first shell will take 2 electrons out of the 6. The next, if the first shell takes 2 electrons out of the 6, the next one we are left with 4 electrons. So that means the second shell will take 4 electrons. And don't forget that the standard is 288. The first shell should take 2 electrons, second shell 8, third should take 8 also. But here we have, for carbon, atomic number 6, first shell 2, which is balanced, second shell 4, which is not balanced, second shell should be 8. So it means the oxidation number for carbon is this. That means carbon has to borrow 4, that means bring in 4, or that is, it has to bring in 4 to become balanced to complete the second shell, or it has to give away this extra 4 to be left with just 2 electrons in the first shell. So that means carbon has to borrow 4 electrons, or give out 4 electrons also. So by the time it borrows 4 electrons, it balances the second shell, that's the second filling, to make it 8. If it gives out those 4 electrons, it makes it become balanced because you end up having just 2 electrons in the first shell. So what does that mean? Oxidation number of carbon, now when it brings in, it becomes negatively charged. That's the radical we're talking about. It becomes -4 when it borrows. When it gives out 4, it becomes positively charged. So the oxidation number for carbon is either -4 or +4. So it can't exceed this. It lies between -4 or +4. So it depends on the kind of chemical compound we're talking about. It could be carbon 4 oxide, carbon 2 oxide, carbon 1 oxide, and and so on and so forth. So it depends. So it's either going to be -4 or +4. That is that for oxidation number. So now, when carbon reacts with other elements in a given compound, we can easily get the radical. So as you can see, these are the hypothetical radicals or hypothetical charge for carbon. It's either -4 or +4. So what is the valency? What's the valency of carbon? Now when you talk about valency doesn't have any business with charges at all. So valency of carbon is just 4, either 4 or 4, just 4. Okay, let's look at another element, nitrogen. Now nitrogen has an atomic number of 7. As you can see, 7. Nitrogen has atomic number of 7. So let us see, according to the electronic configuration, that's the filling of the shells, 288. Now we look at nitrogen, this is what is going to be. The first shell takes 2. Second shell, now out of 7 electrons, 2 is already gone for the first shell. Now second shell must take 8, that's the max. Before we can say balance has been attained, second shell will take 8. So 2 has been taken out of 7, what is left will be 5. So when you talk about oxidation number for this nitrogen, it means all these are hypothetical. Don't forget, that's why we call them oxidation number. So when you talk about oxidation number for nitrogen, it means nitrogen has to borrow 3 to make up those 5 electrons because it's not up to 8. It means it's going to borrow 3, or if it does not want to borrow 3, it has to give out the 5 electron in the second shell to make it balanced. So if it brings in 3, it becomes balanced. If it gives out the 5, it also becomes balanced. You'll be left with just 2 electrons in the first shell. So the oxidation number for nitrogen is -3. When you borrow, when you bring it in, it's minus. When you give out, it's plus, -3 or +5. Now let's just do a couple of calculation on that. Now nitrogen is a gas. Let me just say nitrogen. I don't want to talk about. I don't want to talk about nitrogen molecule. Let me just say just nitrogen, just one atom of it. Now nitrogen, we either bring in 3. To bring in 3 electron. Electron itself is negatively charged. Now when this happens, what will happen? Nitrogen naturally has 0 oxidation number. Now when it brings in 3 electron is -1. That's plus 3 times -1. That's going to give us 0 plus -3, which will give us -3. So the nitrogen gas becomes an aqueous, becomes an anion. This is an anion here, this negatively charged. We didn't do that to the first carbon. Let's see if we can do that to carbon also. It's the same thing. Carbon that's a solid. It could borrow or give away 4 electrons. So if it gives out 4 electrons, that'll be carbon 4 electron giving out. Carbon naturally is 0. That's oxidation number. The oxidation number is always going to be 0 until they react to another atom. So these are just hypotheses. What could happen when they react with another atom of an element? So oxidation number is 0 here, -4, then -1. What will happen then? 0 minus a minus is plus. 0 plus 4 is +4. So carbon becomes an aqueous 4 plus. So this is a radical. This is an hypothetical radical. This radical itself. So quickly, let's come back to nitrogen. You can see that already. Nitrogen, we either word borrow 3 or give out word 5. If it gives out 5, that's going to be the same thing. That's nitrogen gas -5 electron, and so on and so forth. So what is the valency? The valency for nitrogen, valence doesn't have any business with the charge. Valence for nitrogen is going to be either 3 or 5, but basically 3. So yeah, a couple of take homes. So I would love you to get me the radical, the valency, and the oxidation number for these elements. Now the first element is oxygen, and after oxygen, the next element is fluorine. Oxygen molecule, and then fluorine. That's a gas, fluorine gas. If you found this very exposition resource, so please subscribe to this very channel and share this exposition. See you in the next exposition. Thanks.